Okay, so today we are looking at factorizing in algebra. So yesterday and the last day we were looking at expanding. So we had something like 3 times x plus 2. We had to use the distributive rule to expand that. 3 times x give 3 x's, and 3 times 2 gave 6. Okay, there was no issue there. What happens if I had to multiply by an x? So we had Harry and Leo, I don't know what's going on, but stop. Okay. So if I did another one here, xy plus x, it's a bit of a tricky one, but x times y is xy, and x times x is x squared. And then let's do a third example. So this is expanding at the moment. I haven't even done factorizing. I'm just reviewing expanding first. If I have 3x outside the brackets and I want to multiply by x plus 2, something like that. 3x times x squared, well, that'll be 3x. Well, x times x squared, there's going to be 3x's, so it's x cubed. And 3x plus 2 is 6x. So all of these are expanding. From here to here are expanding. Now, factorizing, by frozen. Factorizing is working the other way. It's when you're given an expansion and you want to put the brackets back into it. And that is factorizing. Okay, written really, really small. Okay, so if I remove these from screen and I say factorize 3x plus 6. Oh, well, I have the answer above, but I've removed it now. So what we need to figure out is what's the smallest thing that divides into both 3x and 2? What's the, not the smallest thing, the largest thing that divides into 3x and 2? Yes, 3 divides into 3 and 6. X doesn't divide in. So the common factor of 3x and 6 is 3. So we put that outside the brackets. What's left behind? Well, it's like division, I suppose. Dividing 3x by 3 leaves with x. Dividing 6 by 3 leaves 2. Still plus. That is this, factorized. How do I check? Well, I can expand. If I multiply again, I should get the same thing back. 3 times x gives 3x, and 3 times 2 gives 6. So it is the same thing. But this is the answer. That's it factorized. And that was my answer from up above. Let's look at the second example. xy plus x squared. I want to factorize this. What's common to both? Now there's no numbers this time. So what's common to both? Type in the chat. One is common to both, yeah? Any letters common to both? X? Yeah, a few of you on X. Okay, because X is common to both, 1 is common to everything. So there's no point in taking out a factor of 1. 1 times everything is everything. So factoring 1 is no good to us. But X is common to both, which I can factor out. I'm going to take out. It's a common factor. What's the highest common factor between these two? X. Largest thing to divide in. What's left behind? Type in the chat. What would I write inside the brackets, or what would be my answer? Can you type in the chat? Yeah, Harry has it. Left behind then would be the same thing I had at the start. Y plus x, because it's the opposite way around. X times y gives xy, and x times x gives x squared. And that is this, factorize. And you could check just in your head, x times y gives xy, and x times x gives x squared. Okay, so factorizing is the opposite to expanding. I'll say that again and again. So my last example. (3x cubed plus 6x). Factorize this. Now we should know the answer because, of course, we knew the question earlier on. What's common to both? So you can pick out a number and a letter this time. 3 is common to both. X is common to both. So I'll take out 3 and x. What's left behind? Well, this one has been divided by 3x. So 3 is gone. One of the x's is gone. There's 2 of the x's left behind. X times x. Not x cubed is going to be x squared plus 2. 3 into 6 goes twice. X into x goes, okay, we already have the x outside, so it's 3x plus 2. If you're not sure, just square it out, just multiply it out again. 3x times x squared, well, that's going to give me 3, and another x is going to be x cubed, and 3x times 2 gives plus 6x. So that's the way I'm always checking afterwards to make sure it multiplies back out. So it's the exact same thing as if you had 15 plus 10. What's the highest common factor of both of these? Well, 5. So that can be written 5 times 3 plus 5 times 2. And I write it like that. I can write that, that's no problem. And then 3 plus 2 is 5. And 5 times 5 is 25, which is the same as 15 plus 10. It's the exact same thing. So if you're looking for, let's do highest common factors in the chat. I'm going to give you 2 things, and I'm going to give you 2 things and type in the chat. Let's see if we can get this fastest. This is not to leave or anything, but I'm just looking for the highest common factor of 2 things. I'm going to say 24xyz and 12x squared y. What would be the highest common factor of these 2? Type in the chat. No, it would have to have some letters. It has some letters in common as well. So you have to include the numbers and the letters that are common to both. Still no one has it. 144 isn't a factor. Elon has it. So what's the highest number in common to both? Well, 12 divides into both, 12. What letters are common in both? There's an x in both, there's a y in both. Is there an x squared in both? No, because this one's 12, really x, x, y. You could write that as x squared is x times y. And this has only got 1x, so I can't put x squareds. They're not common to both. So what's common to both is 12xy, and that's the highest common factor. Okay, let's do another one. Highest common factor of 8ab and 16b squared. What's common? Highest common factor, letters and numbers combined. Okay, so there's a number of people have it right here. You can, you have to make sure the number divides into both. If you want, you can split this up into its factors. 8 multiplied by a multiplied by b. And this could be 8 times 2 multiplied by b multiplied by b. If you want to break that up. And then you can see what's common to both. That is in both, so that's common. There's no a on this side, so there's a b, there's a b. So 8b would be the common and all other things are uncommon. Or you can just look at it and go, well, 8 divides into 16 and 8. And b is on both sides, so a b is there, and that's the highest common factor. All right. It's 8b because 16 doesn't divide into 8. 8 divides into 8. 8 is the largest number that divides into 8. Okay. All right, let's look at another one. What about if I just have 6 and 24xy squared? What would be the highest common factor of these two? It's an and. Yeah, we have it. Yeah, it's just gonna be 6. There's no letters here for it to be in common. There is over here, but that's okay. Just take out 6. Yeah, it's just 6. 6 divides into 24, so it's all a go. All right. All right, type in the chat now the answer to if I want to factorize. So that's using the brackets now this time. If I want to factorize, yeah, it was a bit of a weird, not a trick question, but a bit of an unusual question. Let's do AB minus 2BC. And I want you to factorize that. So I want your answer with a bracket in it. No, Matty, you're right. Okay, so what's common to both here? Is there a number in common? No. Is there a letter in common? Yes. B is here, B is here. So B goes outside brackets as the factor. What's left behind? Well, I've already got rid of the B here, so I have A and I have minus 2C left behind. And that's it, factorized. That's it, done. Can't do any more than that. There's no number in common, only a letter. All right, let's do another one. I want you to factorize. Let's take one from your worksheet. Okay. 48 minus 12 cubed. I think Lily and Reese have it. No, Maddie. Okay. What is common to both? Is there a letter common in both? No. So the letter can't go outside. Is there a number common to both? Well, the highest number that's common to both, yeah, Tiana, you could do 6, but I think 12 is the highest common factor of 48 and 12. So 12 sits outside here. So if there's no letter in common, I can't put it outside the bracket. 12 times what gives 48? 12 times 4. And 12 times what gives 12q? Well, I need the q here, so I leave the q behind in there. That unknown. So I can test that if I multiply out. 12 times 4 gives 48. And 12 times minus q gives minus 12q. And that's what I wanted to start. This is the answer. If I want, I can test it like that. All right. Now for the classwork, which will be homework for Friday, the green just asks for highest common factor. Just asks for a question like this, and you just name the highest common factor. That's green. Yellow then will be questions like this: factorize, and just write that. That'll be yellow. Blue then is some of this and then some challenge type questions at the end, which require you to do some division. So if you're thinking of doing blue, just realize that if I have something like this, 3x squared minus 9 divided by x squared minus 3. If I have that, so this is for blue. This is for the harder questions in blue. If I could factorize the top of this fraction, I would get, well, I take out 3 maybe from both these two, and I'm left with x squared minus 3, I think, on top here. And then on the bottom, I'm left with x squared minus 3. There's no common factor to either of those. Okay? But what I have here is the same thing multiplying and dividing. So if I had a different question, and I just said 3 multiplied by 2 divided by 2, I would go, well, there's no point multiplying by 3 by 2 and then dividing by 2. That would just, dividing and multiplying by the same thing would go away. And that's why this factorizing has helped us. Once I factorize, dividing and multiplying by the same thing, exactly the same thing, I'll put in brackets if I want, leaves me with just 3 over 1, or just 3. And that's it. Factorized, then simplified. So in the last questions in blue, you'll be asked to do some stuff like that. Some of them are multiplied, and you can cross-factorize and have a look at it. So that's just a hint. I'll go through the answers to it. And I'll help it on Thursday and give the answers to it on Friday. But green, just common factor like these, and yellow like these, and blue then has a few trickier examples at the end that you can try if you want. Both homeworks are due